Hello everyone. Now let's see how to do analog design experiment inverter using Cadence tool. Now right click on the desktop, create a new folder. I will be creating like delete underscore analog. Then click on create. Open this folder. Right click on create. Click on open in terminal. After this CSH, that is C shell. Then after this source home install CSHRC, that is where my Cadence is installed. Then it invoked my Cadence tool. After that, here I need to give Virtuoso. That is the tool which is used to invoke my analog design tool. So here the window will come. This is called as file manager. So here click on tools, click on library manager. In this, click on file, new library. So here the library name you have to give it as, since we are doing inverter, I am giving INV1. Then I will click on OK. Then third option, attached an existing technology library, click on OK. Then one pop-up window will come. Wait till that time, don't be in a hurry. GPDK 180 is the technology what we are using. Apply, OK. Then whatever INV1 you have created, click on that. Again go to file, new library, cell view we have to create. Go to file, new cell view. So new file is ready. That pop-up window will come. Click on it. Here cell name also I will give it as INV1. So my library name is also INV1, cell name is also INV1. So it will be easy for us to execute. Okay. Then this window will come where we can write the schematic. So here inverter means we have the PMOS in the pull-up region, NMOS in the pull-down region. For that I need to click on I from my keyboard. I means add instance. Library is GPDK 180 and cell is PMOS. Enter. Enter one more time. So we can place over here. Then escape. Then again I from my keyboard. Now I require NMOS. I'll write N. Enter. So NMOS I will be placing here. Then escape. Now I'll be creating pins now. So click on P from your keyboard. So you require 4 pins. One is V in, second one is VDD. Then you require VSS. Vout is an output pin. Now V in space VDD space VSS I have given, and these are input direction pins. I'll click on hide. So V in I will place over here. Then next VDD comes. After placing my V in, I will click on R from my keyboard. It will rotate. I'll be placing over here. VDD is placed. Now VSS is there. Again rotate. I'll be placing over here. Click on escape. Again P from your keyboard. Then here I need to write Vout. Then I need to write the direction as output. Then hide. So here I'm going to place. Escape. Now I need to do the wiring. For that, W from my keyboard. So I need to connect this VDD to this pin, and from here it's not connected. Escape. Again W from my keyboard. From here to here. From here to here. 2 gates I'm going to short. Then this V in I will be connecting to here. Then V out from here I will be taking and connecting to this junction. And I should not forget to connect this substrate terminal of the PMOS to VDD and substrate terminal of NMOS to VSS. Now this is my schematic. Escape. Check save to get the errors. So I have done check save. No error pop-up window came. So F means fit to window. My circuit is ready. Now to check Virtuoso window, here I'll go, and here I can see inverter 1 schematic completed with no errors and saved successfully. So this message we have to see. After this, come to this window again, click on create and then cell view from cell view. Here we are creating a symbol and let the library name, cell name, everything is as it is. Simply click on OK. And here my left pins is V in. So VDD is my top pin. So Control X, selecting that, Control V here. So top pin is VDD and left pin is VSS. So I'm going to write, sorry, left pin alla, bottom pin is VSS. Then my left pin is V in, my right pin is V out, and then my top pin is VDD, my bottom is VSS. So it is perfect now. I click on OK. After this symbol will come, and at part name, this is not required, delete it. And here instance name, delete it. If you want, you can write inverter over here as a text, which is not required. F from my keyboard to fit to window, then again check save. So after doing the check save, you come to this Virtuoso window and check. So here it will say completed with no errors, symbol saved. This information we should get, and we are getting that. Now close this symbol now, close this schematic also now. After that, go to make sure that INV1 library is selected. Go to File, New, Library. Here, sorry, cell view we have to create. So File, New, Cell View. Click on this. Now library is INV1 itself, and cell is INV1 underscore test, because I'm going to write the test circuit now. So this is schematic window itself. Click on OK. Now this window will again come. Add instance I, you click. Now you have to use the symbol which is generated from your library. Your library is INV1 library. So INV1 I have selected. My cell name, you click the arrow mark, it only will show. INV1 you select and then click on hide. So this symbol will come like this in a box type. Hide it, escape. Now again you have to click on I, add instance. Now here you have to select vpulse and VDC. For that you have to select your library as analog lib, and the cell is vpulse. Enter 2 times. So vpulse you can place over here. So I have placed. I'll click on escape. I'll click on this particular vpulse. The rose color box will come. I'll click on Q, which is nothing but properties. I need to edit the properties now. In the vpulse, voltage 1 is 0, voltage 2 is 1.8 volts, and the period is 20 nanoseconds. So we can write simply 20 nanoseconds, it only will take. Delay time is 0, rise time is 1 nano, fall time is 1 nano, pulse width is half of the time period, which is 10 nano. My time period is 20 nano, pulse width is 10 nano. Then I'll click on apply and then OK. So now again I from my keyboard to add VDC from the analog lib. So VDC is what I will type here in the cell region. Then I'm going to click on hide here. So I need to place, before placing I need to make sure that I need to rotate this in a proper manner, and I need to place this particular VDC after this VDD line. So then I can do nice wiring. So I have placed it. Click on escape. Now I need to edit these properties. Select this, press Q. So the voltage I'm going to give here is, the DC voltage I'm going to give here is 1.8. I'll click on apply and then OK. Then I need to place my ground pins, as well as I need to have a capacitor also. I from my keyboard, then over here cap, CAP, enter. So capacitance I'm going to type here, escape. Select this, Q, and here capacitance is 0.1 picofarad. So 0. I'll add. So 0.1 picofarad means 100 femtofarad. It will come as it is. Now click on apply and then OK. Now ground I need to write. So I from my keyboard, let it be analog lib itself. G and D is what I need to type and enter. So G and D I have typed, and I'm fixing here. Below VSS 1 I require, below capacitance 1 I require, below VDC negative I require one more. Then escape. So total 4 grounds I have placed here. Now output pin I need to place, for that P from my keyboard. So let it be output itself the direction, and V out is the name I have used. If you have used V0, V0 in the schematic design, and in the test circuit design also you need to use V0 or VO only. Still I have used V out there. Here also you need to use V out itself. Click on hide, place it in the straight region, escape. W from your keyboard to do the wiring. I'm doing the wiring now. V out I have connected, capacitance positive terminal I have connected, capacitance negative terminal to ground. We need to connect VSS to ground. After that we need to connect positive of V pulse to V in, and then from negative of V pulse to ground. Then from this VDD of the symbol to VDC positive terminal, VDC negative terminal to ground. So these are my connections. That's it. Escape from your keyboard and F from in your keyboard to fit to window. Now all values are ready now. So now you need to do check save. So check save I have done. Now I'll check whether any error is there. Inverter 1 underscore test schematic completed with no errors, and schematic is saved. So this message should come. So after checking this message, come to this window again and click on save. You have done it. And after check save, go to launch, click on ADEL. Now this particular window will come, ADE window. Maximize this window. Come to setup, model libraries. Here I am using 180 nanometer technology. So apart from that, other whatever ticks are there, you need to disable that. So make sure that only 180 nanometer is selected. Click on apply. OK. Now go to analysis, choose transient analysis. In this stop time I'll take it as 200 nano. Moderate I will select, and then I will click on apply. Then transient is done. Now DC analysis I will click. Now here save DC operating point I need to select. Component parameter in the sweep variable I need to select. Inside this component parameter, select component I have to click. Then I need to select input V pulse. So here DC voltage will come. Select this, click on OK. Then after this, come to choosing again. Here start time you take it as 0, stop time you take it as 1.8. So after giving the sweep range, sweep type is linear, step size is 0.01. Then after this, click on apply, then OK. Now come to ADE window again. So here you have analysis part. Go to outputs, click on setup, click on from design, select the input line, output line, come to setting outputs. Everything is selected here. Click on apply, OK. Come to AD window again. Now everything is selected. Now you can directly click on play button. So that green color play button I have clicked. So we are getting the output. So the code is running. So this is the waveform what we got. So this is your transient response, where with respect to time we are measuring the transient response. I'll click this and I'll click on split all strips to see the output clearly. Here we can see that net 1 is my input, V out is my output. So here when my input is 1, I'm getting 0 output. When my input is 0, I'm getting 1 as my output. So like that it is running for 200 nanoseconds. Now this is our DC response, and this also I will strip so that I can see clear thing. So this is my transfer characteristics or DC response of an inverter. So here region A, B operation is this, and region C operation is this, where my NMOS and PMOS both are in saturation region, and region E and region D operation is this. So this is my DC response I'm getting correctly. Then I need to calculate the delay from this transient response. For this I will select on V out. On the waveform of V out, I'll right click, I'll click on send to calculator. So after clicking on send to and then calculator, I have to see what comes here. So the calculator window came here. Stack will be there. This is not required. You close this. Then here Fn will be there. This Fn you click. And here delay will be there because we need to calculate the delay. So select the delay. Now you signal 1, control A, delete. Signal 2, delete. Now here whatever Vout came, you select this, control C. You click on this function, you paste over here, and that is my net 1. So what I do here, in place of Vout, I will write it as net 1. Signal 1 only I will consider as input. Now threshold value is half of the the maximum value, which is 1.8 is maximum value. 0.9 is what I am going to write here. Threshold 1, threshold 2, edge number 1 and edge number 2. Edge type 1 is rising, edge type 2 is falling in the first case. That means I am finding from rising edge to falling edge. Then after this apply, okay. Then this formula will come here. Before append there is evaluate button, click this. We are going to get the delay value 20.19 nanosecond. That's it. Thank you.